Greetings. This is team number 3 called Lowell. In this presentation, we will give a preliminary design review of our proposal to evaluate if it meets the performance requirements needed to process into detailed design. These are the main topics we will review in our presentation. Our team is organized in the following arrangement. Luis Enrique as our team leader. Leslie Priscilla is in charge of overseeing the design. I, Diego Prieto, I am in charge of keeping the project organized and managing the important dates. And Diana Cristina is in charge of overseeing the mechanical concepts. Mission Summary. The primary objective of our mission is to design a CanSat that shall consist of a container and two auto-rotating maple seed science payloads. The container shall contain electronics to release the auto-rotating maple seed science payloads and relay data from the payload to a ground station. There is also a bonus objective given every day, and each team can decide whether to pursue it or not. Our team decided to include it in our proposal. It states that a video camera shall be integrated into the container and point towards the ground. The camera shall capture the release of both science payloads and capture the descent of the science payloads. Next, we present all of the requirements that need to be fulfilled in order to create a successful CanSat model. When creating our two concepts for the design of our CanSat proposal, we use two different types of processes. The first one comes from an unstructured process that is called brainstorm. According to this process, the system should incorporate these points. Number 1. Use recycled materials to reduce the total cost of the project. Number 2. Use an Arduino Uno to manage the sensors that give us important values, like pressure, temperature, and etc. Number 3. Use an LCD screen for the Arduino to display all of the important values. Number 4. Use a pre-built battery, like a power bank, to avoid failures. Number 5. Use an Apple AirTag as an alternative for a beeper and a GPS. Number 6. Use a camera. Number 7. Use a humidity sensor. Number 8. For the payload descent control, we will use a non-electrical mechanism to avoid failures. Number 9. Use a protective cover for the fragile elements. Number 10. Integrate an accelerometer to the Arduino. The second concept design came from a structured process called mind map. According to our mind map, our proposal should include low cost due to recycled materials, the functionality of an Arduino, an LCD screen, an AirTag, and a power bank. The characteristics should include a rocket and deployable wings. The tools should include a barometer, a thermometer, and a GPS, each with their own mission. And the mission should be to obtain the humidity at a certain altitude, plus recording all of this in live feed. Here, we evaluated which one of the two concepts is the best option for a proposal. Due to the limited time and the current sanitary situation, we weren't able to fully complete all of the steps. So we started by supposing the attribute values that we should have gotten from the questionnaire interviews, that are already normalized to get the total value of the utility of 1. To make the multi-attribute utility analysis, we graphed the different concepts we got in the brainstorm and mind map processes, where we evaluated these points against the utility we considered it, and we put them against in the attribute values. Each point represents the different concepts of each process. As many of the concepts were the same for both processes, the graphs are very similar. The graphs are shown in the next slide. For our final concept, we base our decision on both the mind map and the brainstorm, as we believe that both of these processes gave plenty of good ideas. The main idea was the best use possible of the Arduino as a microcontroller when adding such elements as a humidity sensor, a barometer, and the LCD screen. The mission to simulate, we believe it could be a search of water in the landing point, which could be difficult or dangerous. The addition of the camera will help to record the mission and to obtain visual information of surroundings of the landing area, as well as monitoring the mission all throughout. All these elements will serve their purpose mounted on the delta wing. Other simple ideas, like mechanical release of the delta wing to avoid any failures, the AirTag as GPS/beeper, and the separate power bank will serve to complete the mission at its fullest, as they serve independent from other elements, but still they all work together in harmony. Here, our system concept of operation is shown. The illustration shows how the launch sequence takes place. The payload is located inside the payload chamber. This chamber is attached to the main body of the rocket by a string, which also contains a parachute with the purpose to recover the main body of the rocket. The CanSat has its parachute attached at its bottom, while on its top lays the parachute of the nose of the rocket. When the rocket is launched and reaches its desired altitude, it will break into three sections: the main body of the rocket, the CanSat, and the nose of the rocket. The main body of the rocket detaches from the payload chamber, but remains connected by the string. As this occurs, the CanSat slips off from the payload chamber along with the nose. When a certain altitude is reached, both parachutes from the CanSat and the nose deploy to break their falls. As they keep falling, they will arrive at the designated landing area, thus to complete the CanSat objective. Now we will deepen into the sensor subsystem design. Here, the requirements that apply to the sensor subsystem are shown. With the purpose of verifying that our choice was the best for the project, we compared three GPS devices to the AirTag, scoring them on aspects like cost, dimensions, reliability, sustainability, range, and functionality, giving them certain weight according to their importance in a POG matrix. Here, we can discard the first option because of their negative result. The most similar option to the AirTag is the tile. Meanwhile, the ticket star has many different characteristics, but its advantages complement the disadvantages, making it an alternative similar option. Finally, we decide to choose the AirTag because we consider that in our team it could be the better integrated, as most of us have decided that the device can easily be connected and interacted with. For the second POG matrix, we search for some camera alternatives that could be used for the mission, while comparing them to a camera-based model that is usually used in many projects like this. For the alternatives, we have an Arduino module integrated camera, a separate module that just needs to be connected to a power source, and an independent mini camera that has its own battery. After this POG matrix, we decide to change the camera to the second option, as we notice that is way better option, as the only disadvantages it has is the video quality, which is a little bit lower but still acceptable. While in the other criteria, it has more advantages in terms of cost, dimensions, and functionality. When generating the descent control design, there can be no mistakes. The main objective of the mission is to have the payload descend like maple seeds. They should spin rapidly enough so its descent rate is less than 20 meters per second. Here are shown all the requirements that need to be fulfilled in order to have a successful descent control. For the mechanical subsystem design, we show the requirements that need to be met in order to make sure our system is built without mistakes. The communication and data handling subsystem design focuses on all the information that needs to be obtained from the mission and how to manage it. Here are shown the communication and data handling requirements specific to the container. The electrical power subsystem design focuses on all the components that allow our system to function properly and fulfill its expectations. Here we have the requirements that need to be met for the electrical power subsystem. For any mission to be successful, there needs to be a complete understanding of the logistics on launch day. We can separate launch day in three different moments: arrival and preparation. This is the time to set up antennas, ground station, and final CanSat test and preparations. Then you are ready for launch. The launch of the CanSat is done in groups of 5. Each team will be assigned a round which will be scheduled in 1/2-hour increments. 15 minutes before the launch round, the teams assigned to the round shall retrieve their CanSat, turn it on and insert it into the rocket payload. The CanSat must be flight ready, and the only thing that can be done to the CanSat is to turn on the CanSat with the power switch. After the team needs to recover all the elements and clean up their setup, here all the data gathered needs to be analyzed in order to be able to deliver of telemetry data to the judges. In order to have a successful launch, teams need to coordinate among themselves and with the flight coordinator. Team members need to be assigned to specific tasks and develop a checklist for a successful flight. Mission Control Officer. This person is responsible for informing the flight coordinator when the team and their CanSat is ready to be launched. This role was assigned to Luis Enrique. Ground Station Crew. This person is responsible for monitoring the ground station for telemetry, reception, and issuing commands to the CanSat. This role was assigned to Leslie Priscilla. Recovery Crew. This person is responsible for tracking the CanSat and going out into the field for recovery and interacting with the field judges. This person is responsible for making sure all field scores are filled in or loss of points will occur. This role was assigned to Diana Cristina. CanSat Crew. This person is responsible for preparing the CanSat, integrating it into the rocket, and verifying its status. This role was assigned to me. During the time we spent studying and investigating this competition, we realized there is great work behind any system. We could say we focused on the design process, which we learned is complex and long. In order to be able to offer a good product, there are countless hours of preparation. We were able to understand what subsystems make up the whole of the system, and when preparing these modules, it is easier to have a proposal that will meet at its fullest all the actions that are expected. Accomplishments. Knowing in detail what the CanSat competition is and how you can be part of it. Unfinished work. We consider the CanSat incomplete because we did not get to build it under the present circumstances. Thank you for listening. We will be ready to answer any of your questions in the comments.